Let's go to the next topic of the hydraulics module. Let me share my screen. So the second topic of the hydraulic module is about work done. It's broken down into two topics: work done against pressure and work done against a heat. Okay. So let's look at work done against pressure. Okay. Now, this is everything you already know. It just depends what are you given and how much you express work done based on what you are given. So work done had always been force times distance since N1. But when you are working on a vertical plane, you remember distance becomes height. So we express distance in terms of height. So work done becomes force times height. So instead of distance, we now have height. But if you express your force in terms of gravity, then F becomes mg. And then your work done will then be mg for force and h for distance. And this is on the formula sheet. You remember mgh equals to EP. And remember that EP at the top equals to EK at the bottom. So they can ask you to calculate kinetic energy, and they've only given you the mass and the height. So you must remember that EK at the bottom is EP at the top, and EP is mgh, and mgh is work done. If you have to express force in terms of pressure, remember that pressure is force over area. Therefore, force is pressure times area. When force is pressure times area, so work done will be pressure times area times height, because the pressure times area stands for force. So this is force times distance. Distance is the height, and pressure times area is the force. But area times height equals to volume. Therefore, we can say, instead of area times height, we can have work done is pressure times volume. And this formula is on the formula sheet. And if you express pressure in terms of density, pressure is density times gravity times height. So work done will be, instead of pressure times volume, it's going to be density times gravity times height times volume. But remember, volume is area times height. So work done can be density times gravity times height times area times height. So that's why I said this is everything you know, just depends how you need to express it at a specific moment. You'll be guided by the question. Okay, so let's look at a question. A single acting pump is used for irrigation and it has to deliver 70,000 liters of water per 60 minutes at a pressure of 500 kilopascals. Calculate work done in 60 minutes and the output power. So let's look at our page. So here's the same question. First thing I need to remind you is that 1 cubic meter equals to 1,000 liters. So this volume will be 70 cubic meters. You'll divide it by 1,000 to change it to liters because it must be in liters. So let's write down our given. Volume is 70 cubic meters and the pressure is 500 kilopascals. This happens in 60 minutes. First question, calculate work done in 60 minutes. If we have pressure and volume, work done will be pressure times volume. Pressure is 500, volume is 70. Okay, so that's gonna be 35000 kilojoules because the pressure was in kilopascals. That's going to be kilojoules. That's the first question. Then the second question says we must calculate the output power of the pump. So the formula to calculate power, it says work done over time. The work done is 35000. The time is 60 minutes. We want it in seconds, okay? So this divide by 60 times 60. It gives us 9.722 kilowatts. It's in kilowatts because the work done was in kilojoules. Okay. That's the first question. Then the next question can be this one. A pump supplies, this volume is already given in cubic meters now, of water per minute to a height of 20 meters. Calculate the pressure in kilopascals at which the pump operates. Okay, so this is transporting what a pump supplies water. A formula to calculate pressure equals to density times gravity times height. The density of water is 1,000. You will get it from that constant page. G is 9.8 and the height is 20. So that pressure will be 1,000 times 9.8 times 20. That's 196. I can make it kilopascals. You see the answer I got? So I can make it kilopascals because they wanted it in kilopascals. 6, and that was first question. The second question said the work done by the pump in 30 seconds. So work done is pressure times volume when you are given volume and you've got the pressure. So 196 times 1.5 will give us 294 kilojoules. Okay. Then the next thing, which is the last thing about hydraulics, is then this part of the head. Yeah, this is the situation where you have, let me say you have water in a bottom level in a dam, then you are using a pump to suck the water and deliver them perhaps into a tank. So the total height here from the surface of the water to where the water is delivered is called the starting head. But the height between the center of the pump and where you suck the water is called the suction head. So the head means the height. And the length or the height from the center of the pump to the point where you deliver the water is called the delivery head. So sometimes they ask you, they give you the suction head and the delivery head, and they want you to calculate the static head. So the static head is the overall of these two. And that's basically all. So when it comes to work done, it just depends what is it that is given for you to know what formula to use. Okay, thank you.